Hi, this is Mr. Mack. Now, this is a concept video where we're going to be talking about inferential statistics. The whole idea behind why statistics exists is people want to know what the general population is thinking about something or doing or being or something like that. In other words, they want to know what everybody thinks. Well, see, if the group is small, if everybody is a small group, then you could just ask everybody. But once the group gets to be large, it becomes fairly difficult to ask everybody. So what we do a lot of times is we take a look at a relative sample, a random sample from that larger group, and we look at what they're thinking, and then we try to make inferences about what everybody is thinking from a smaller group. Now, I understand when this is first described, it sounds like this particular plan is fraught with danger, and it really is. But we have found over time that in a lot of cases, this does not turn out to be that bad, or in other words, about a lot of things we can really tell what is going on. So inferential statistics is looking at random samples and making statistical inferences about larger groups from it. Now, when we do make a statistical inference about a larger group, a lot of times you'll be quoted what is called a confidence interval. In other words, we would say that we are, say, 95% confidence that somewhere between 30% and 35% of the population likes, some musician or spaghetti with meatballs or something like that. In other words, something. So usually this is abbreviated CI, confidence interval, and it's going to look something like this. The confidence interval is going to be X bar plus or minus, and there's going to be a number here. Now, the book uses 1.96. That's the number that you would use for a 95% confidence interval. In other words, we are 95% confident, or 95% of the time we would expect the actual population value to fall in this interval, but it doesn't end there. 1.96 times S over the square root of N. Now, S stands for the standard deviation, I can do this. Let's try this again. The standard deviation I don't know what's wrong with me spelling today. Anyway, deviation from the mean. And again, this is S is the standard deviation of the sample, not of the entire population. And N is the number sampled. Obviously, if you want the confidence interval to be narrow, then you would use a larger sample. Now, a couple of other numbers here. These are not in the book, but if you want to be 99% confident, 99% confident, E-N-T, confident, you would use 2.58 in this particular spot. Now, I don't know if anybody would ever want to be 68% confident, but if you wanted to be 68% confident, you would use 1.00 in that particular spot. So those would be numbers that you need to remember. Now, most of the time, well, actually, for all the problems in the book, 1.96 is going to be what you're going to be using. I have no clue about the EOC on that, but those are the numbers for confidence intervals. And so that would be how you would come up with a confidence interval. Now, the next thing we talk about in inferential statistics is a thing called hypothesis testing. Now, in hypothesis testing, what you're going to be doing is you're going to be stating something like, I think the mean of the population, your hypothesis, the mean of the population is, let's say, mu equals, we'll just say 6, okay? Now, we would call this H naught, okay? You have some evidence to believe, you've taken a sample or something like this, you found the mean of that sample, you say, I believe the mean of the population is 6. So H naught, the null hypothesis, this is called the null hypothesis, would be that the mean of the population is 6. Then you have H sub A, and this is the alternate hypothesis. And the alternate hypothesis is going to be the same one, but you're going to change the relation symbol. The mean of the population is, okay, mu and 6. Now, you could have greater than 6, less than 6, not equal to 6, one of these. Now, ordinarily, what we do then when we're doing testing is we take a look at the confidence interval and we see if our experiment or our random sample falls within a 95% confidence interval or a 99% confidence interval. And then if it does, what statisticians do is we say, we are going, okay, if the statistical test has the mean fall within, say, a 95% confidence level, a confidence interval, then this is what we say. We are going to fail to reject the null hypothesis. In other words, in most statistical tests, or when you're doing inference testing with statistics, it's usually set up so that it's pretty easy for the null hypothesis not to be rejected. So a lot of times the statistician will actually want to say, well, I think the mean of the population is greater than 6. But to set the test up, he's got to come up with the null hypothesis as the mean is 6, and then run the test and find what your sample mean is, and then find the confidence interval. And if it's outside the confidence interval, then we reject the null hypothesis in favor of the alternate hypothesis. But if it's not outside the confidence interval, what we say is we fail to reject the null hypothesis. That's, as you can see, that's probably not a ringing endorsement that mu is 6, but we're just saying we didn't find any evidence to say anything other than it was. And that is hypothesis testing. And actually, that's all there is in this particular section. So you might want to read it again and then work on some of the problems and have fun. We're finished.